Today's lesson is called Solution Sets to Simultaneous Inequalities. So for the opening exercise, I'd like you to consider the system of inequalities shown below. Determine if each of the following points is a solution or not to the system. Show work that justifies your answers. So I would like you to pause the video at this point, try the opening exercise, and then resume the video when you're ready to discuss. Okay, now that you had a chance to try the opening exercise yourself, let's go over the answer. So it said, consider the system of inequalities shown below. Determine if each of the following points is a solution or not to the system. Show work that justifies your answers. So you can see above each coordinate pair, I wrote an X and a Y. Remember, X comes first, Y comes second. And I had to check that point in both inequalities. So you can see the first one I did was X plus Y is greater than 8. So I plugged in 2 for X, 9 for Y, 11 is greater than 8. Then I plugged in 2 for X again, 9 for Y again in the second inequality. Y is greater than or equal to 3X minus 4. And it turned out to be 9 is greater than or equal to 2. So because it satisfied both inequalities, it is a solution. So you can see I wrote that underneath. Then when I tested 7, 3, plugging in 7 for X and 3 for Y, in X plus Y is greater than 8, we get 10 is greater than 8. So it works in the first inequality. But when I type it into or plug it into Y is greater than or equal to 3X minus 4, 3 does not end up being greater than or equal to 17. So because it did not satisfy both inequalities, it is not a solution. And then a similar thing happens in part C with 3, 5. 3 goes in for X, 5 goes in for Y. The first inequality fails this time. You get 8 is greater than 8. 8 is not greater than 8. It would have to be or equal to, which it isn't. So that inequality is not true. In the second inequality, it does work because it says 5 is greater than or equal to 5, which is a true statement. But again, because it doesn't work in both inequalities, it is not a solution to your system of inequalities. So very similar to a system of equations, your answer has to work in both. Okay? So now let's move on and do an example. In example 1, it says graph the solution set to the system of inequalities. So I'm going to walk you through the steps, but I've also listed them for you so that you can refer back to them and kind of follow step-by-step directions. Obviously, testing out points like we've talked about before is not the best solution. So what we want to do is graph both inequalities on the coordinate grid and identify the solution set from there. So very similar to how we would graph a linear equation, we still want y equals mx plus b form, but there's a couple extra things to consider. So we're going to graph just the first inequality, which is x plus y is greater than 8. I want y to be alone on the left, so I'm going to subtract x from both sides, and I get y is greater than negative x plus 8. I'm going to put it in mx plus b form. I'm going to continue the way I would if it was an equation. So I'm going to find my slope, which is negative 1 over 1. Which means I'm going down 1 to the right 1. And I'm still going to find my y-intercept, which is 8, which means the first point that I'm plotting is 0, 8. But this is where things change a little bit. Remember, we have to consider whether it's dotted or solid, and we have to consider where to shade. So that is a reminder under step 1. So because it's strictly greater than, not, or equal to, we are going to make a dotted line. And when it comes to figuring out where to shade, you want to check a point. If that point works, shade towards it. If that point does not work, shade away from it. So the point I like to pick most of the time is 0, 0, because I can do it quickly and efficiently. So I'll put in 0 for x plus 0 for y is greater than 8. 0 greater than 8 is not a true statement, so I know I'm not going to shade towards 0, 0. So we'll come over to the graph. We'll plot 0, 8 first. And then remember, we're going down 1 to the right one, down 1 to the right one for as many as you need. Then you will grab your straight edge and connect them, but when you connect them, it should be dotted. The dotted line shows that anything on the line does not count as a solution. So I have my dotted line, I have my arrows, and then remember we tested 0, 0 and it did not work. So we are going to shade the opposite way, not towards 0, 0, but away from 0, 0. And then we will also label with the original inequality of x plus y is greater than 8. So now we will plot our second inequality. This one is y is greater than or equal to 3x minus 4. So we already did step 1 and 2. We graphed the first inequality. We considered where to shade and dotted or solid. We labeled it. Now we're going to repeat that process again. So graph your second inequality. Make sure you think about dotted, solid, and where you should shade, and make sure you label. So 3 and 4 is what we're going to do now. So this is already in the mx plus b form that we like. So I can write m is equal to 3 or 3 over 1, which means I'm going up and right based on my rise over run. And my y-intercept is negative 4, which means the first point that I'm going to plot is 0, negative 4. Because when I look at that it's greater than or equal to, I know that it's going to be a solid line because everything on the line will count. And I'm going to test the point 0, 0. So 0 in for y and 0 in for x. So this would be 0 is greater than or equal to 0 minus 4, which means 0 is greater than or equal to negative 4, which is true. Okay, this one works. So we are going to shade towards 0, 0 for this one. So we are going to start at 0, negative 4. Our slope is up 3 to the right 1. If you run out of room, remember you can go down 3 to the left 1. When you connect this one, because it's or equal to, all the solutions on this line actually count. So it's solid. And then remember we said 0, 0 did check. So we want to shade towards 0, 0. Now, don't make your shading too complicated or it's going to be hard to see where the solution is. If you keep it as kind of some simple lines, then you can easily tell that when you look at this graph now, there's a double shaded region where the shading overlaps, kind of looks like crisscrossing, okay? And in that double shaded region are all the possible solutions for your solution set. So number 5 says the solution set is the double shaded region where the shading overlaps. Number 6 is our final step. We want to take and mark this with an S so we can clearly see where the solution is. So we're going to put a big giant S in the double shaded region. And then we know that any point in that region is going to be a solution to the system of inequalities. So now let's go on and look at example 2. It says, on the grid below, graph the solution to the system of inequalities shown below. State a point that lies in the solution set and one that doesn't. So we will start with the first inequality. It's already in proper form. So we've got m equals negative 3 over 2, which means I'm going down 3 to the right 2. And the y-intercept equals 4, which means the first point that I'm going to plot is going to be 0, 4. Now, when I consider dotted or solid, I see it's less than, so it's going to be dotted. And then I want to check the point 0 to 0 to see if I should shade towards that or away from it. So I'm going to plug in 0 for y. I'm going to plug in 0 for x. Then 0 is less than, that's going to be 0, and this is going to be 4. So 0 is less than 4 does work. So we can go over to the coordinate grid. We're going to start at 4. And we're going to go down 3 to the right 2. Down 3 to the right 2 for as many as you need. You can also go up 3 to the left 2. And then when we connect it, we are going to use a dotted line to show that anything on that line is not included. When we checked 0, 0, it worked. So we are going to shade towards 0, 0. And then we are going to label our inequality with y is less than negative 3 halves x plus 4. So for the second inequality, you see there's only one variable. So we talked about these before. We are going to plot this as if it's x equals 2, which means that no matter what my y is, my x is always going to be a 2, no matter what my y value is. So I'm going to plot these points, 2, 1, 2, 2, 2, 3, and you can see it's creating a vertical line at x equals 2. So this is going to be on x equals 2. It's going to cross it, so it's going to be vertical, and I'm going to make it solid because it's greater than or equal to. So this is where x is equal to 2. And because it said x is greater than or equal to, we are going to shade to the right. That's where all the values will be greater than or equal to an x value of 2. And then, of course, we are going to label it with x is greater than or equal to 2. Now, we want to mark our solution set by identifying the crisscross portion. So that's going to be this portion in here. And then we want to identify a point that's in the solution set and a point that's not in the solution set. So a point that would be in the solution set is easy to pick if you kind of go to the clearly crisscross area. So I'm going to pick coordinate 4, negative 5. It's right here. 4, negative 5, it is definitely in the solution set. Now I have to pick a point that's not in the solution set. So you could pick one that's only in the blue, only in the green, or I'm going to pick one that's a special scenario. I'm going to pick the point 6, negative 5. And the reason I'm picking that one, 6, negative 5, is to remind you that that cannot be a solution because it's on the dotted line. All right, so that's a nice little reminder. Now, as a challenge conclusion to this lesson, I would like you to try the following question first and then resume the video to discuss the answer. So you're going to compare systems here. You're going to solve each system by graphing. In part A, I want you to graph the system of equations. You can see there are equal signs. In part B, I have kept the same y and the same x plus mx plus b, but I have switched to inequality symbols instead. And I'd like you to write down after you graph both of these systems, what do you notice? So at this time, could you pause the video and then resume the video when you're ready to go over the answer? And so now that you had a chance to try, here's a chance to check your answers. So for y equals negative 3x plus 5, the slope was negative 3 over 1. You should have gone down 3 to the right 1. Your y-intercept is 5. For y equals negative 3x plus 8, your slope is negative 3 over 1. So you go down to the right, but you're starting at 8. So when you graph these, you end up with no solution. These are parallel lines. They're never going to cross, so there is no solution. And you could have told that as well by looking at the equations. They have the same slope, so they're slanted the same way, but they have different y-intercepts. Now, by changing the equality symbol, equal sign, to inequalities instead, there's shading involved. And so what happens in B is you graph them the same exact way. But when you test your points, the green one, the one I did first, y is greater than negative 3x plus 5, you end up shading kind of up and to the right. The second one that I did in purple, y is less than or equal to negative 3x plus 8, you end up shading kind of down and to the left. And in that very teeny tiny small center, you can see I put a letter S, and I kind of tried to put arrows showing you that the solution set is in that small space between the green dotted line and the purple solid line. So here, it actually changes it from being no solution to being infinitely many solutions instead, because your solutions are all falling between y is greater than negative 3x plus 5 and y is less than or equal to negative 3x plus 8. And you can actually include the points on y is less than or equal to negative 3x plus 8 because that line is or equal to and solid. So that concludes your lesson on solution sets to simultaneous inequalities.